Now that the concept of the divide and conquer is clear, and the concept of the merge procedure is also clear, like not the algorithm, I'm just saying the concept. Let's see how will the merge procedure work, how will it work, and how will it be applied to, let's say, to a real problem. Okay. Here, let's start. First, let me just say that the merge procedure will take. I mean, the running time of the merge procedure is of order n. Here we will see what is the theta. Maybe you have seen the big O, but not the theta. This will be introduced in the next chapter, the complexity analysis, um, the growth order. So here we consider n, which is equal to r minus p plus 1. It's like we have an array that starts at p and ends at r, and n is actually the length of this array. So it is the number of elements being merged. So what we want to merge actually. Um, so we will have actually two piles of cards face up on a table. So the two piles are the two subarrays. Each pile is sorted with the smallest cards on top. So the first subarray is sorted, the second subarray is sorted, and what we want actually is to combine these two sorted subarrays into one sorted array. So the goal is to merge the two piles into a single sorted output pile. Okay. What are the basic steps? The basic steps are choosing the smaller of the two cards on top of the face up pile. So we'll choose the smaller from the two piles, or from the two subarrays. We'll choose the smallest element and remove it from its pile. And then place this card in the output pile. Then also from the two, we will choose the smallest. Every time we choose the smallest until this is done. And actually we know that when we say the smallest, we will start by the first element, second element every time, because the two subarrays are sorted. So we repeat the three above steps until one input pile is empty, and at which time we just take the remaining input pile or the remaining of the other input pile and place it in the output pile. So let's see here an example of this. Here we have two piles. The first pile, which is a subarray of 4 elements, similarly for the second. So the elements from 2, 2, 4, 5, 7, 1, 2, 3, 6. So what we will do to select the smallest element from these two, so we'll select the 1 and we will place it in the output pile. Okay. Then the 1 is just removed, so we will select the smallest from these two here, from these two piles. Without considering the 1, we will find 2, either this one or this one. So let's say, for example, we chose this 2. So this will be removed and will be placed here, like what we did here. Okay. Then the smallest is the 2, will be removed and placed here, like here. So this is removed and placed here. We continue. Here we select the 3, which is the smallest, and we placed here. Then we select the 4, we removed it and we placed here. Then we select the 5, we removed it and we placed here. Then the 6, then the 7. Okay, and that's it. And here we have the output pile that is sorted. Now, before I introduce the algorithm, I will let you think a little bit about how to do this algorithm, and why is the complexity time of order n.